Oh, cool. It's recording.
Wait. Oh, yeah. So for this week, the activity name is Modelling Earthquakes and Interior Insights. Has everyone had a chance to just skim over it?
I haven't. Sorry. I sort of know that we're modelling how the tectonic plates move with plasticine and eggs, but I haven't completely read the thing.
That's all good. I think I have to explain it anyway. So the research question I thought could be how tectonic plates affect the Earth's surfaces, because that's mainly what it's about. So,
yeah.
And then for Australian curriculum, I found that it relates most to Year 6 and Earth and Space Sciences, which is the sudden geological changes and extreme weather events can affect Earth's surfaces. And then the two elaborations from that I thought related were investigating major geological events such as earthquakes, volcanic eruptions, and tsunamis, and then recognizing that earthquakes can cause tsunamis, because they both relate to earthquakes.
Yeah.
Can paste that in.
Does someone want to share the document to the screen?
I would have so many things up right now.
My team's just said it needs updating, so I might have to access it on my phone again.
Give me 2 seconds and I will share it to the screen. Let me just see.
Thank you.
No, that's all right. Because I have to log in everywhere again. It's so frustrating.
So basically what I'm going to do is I have some plasticine, and we're just going to push them together, pull them apart and slide them past each other to see they're acting as the tectonic plates or plate tectonics. And we'll see what happens to them. And then we basically do the same with some bricks on top. And then we do the same with an eggshell. And then the last one's just cutting open an eggshell to kind of see. I don't know if I'm allowed to say that yet, but yeah. Yeah. The plasticine isn't the right size. It said it has to be 10 by 20 centimeters, and I didn't want to buy that much, so it's just quite small. But yeah, I was like, I got a ruler, and I was like, nah. So they're this big.
That'll do.
So cows move softly. So we'll do all the things that could be changed. What do we think they are? I mean, we could obviously the size of the, yeah. Pieces.
We write these up the top?
Sorry?
Do we write these things up at the top?
Yeah.
Sorry, I'm trying to log in to be able to do it.
I guess the strength I use to push them and pull them.
The force.
Yeah.
The type of plasticine you used?
Yeah, I think some groups use Play-Doh, which I wish I did because it's so hard, the plasticine.
Plasticine's what they put in packing, isn't it?
I don't know. I don't think so.
I don't think it is.
Oh. It's what they make
It's it's very hard, Play-Doh, really hard.
Oh.
It's like clay, isn't it?
It's
yeah. Styrofoam ash?
What was that?
I think you're thinking of styrofoam.
Yeah, I am. I am thinking of styrofoam. Yeah. Right. I'm on the same path now. I get what it is. Why are we using that?
Do we think that's all we could change? I think it is.
Yeah.
I guess The eggshell doesn't really change how long you
Like-
cook it for.
The length of
Yeah.
time that you push them together for.
Yeah.
Yeah.
Or how fast you slide it past, I guess.
Yeah.
What sort of
We
surface
could probably
would that,
Yeah.
like if you do it
Yeah.
on the bed, obviously it's going to be different to if you do it on the ground.
Oh, surface. Yeah.
and maybe
I guess the shape as well. Mine's kind of like a oval.
yeah. Wait, are we writing these down? I just can't see it on
Yeah.
my
I'm sorry,
thing.
it's taking forever to log in. I don't know why it's taking so long. I won't share it.
Yeah, now it's telling me I need to sign in as well.
Must be a team.
But also we could change the temperature. So like if you
Mm.
put the plasticine in the freezer or if you heated it in the microwave or
Yeah, my sister was like, why don't you just put it in the microwave so you can bend it? I was like, oh, I don't want to start a fire. I feel like that's all.
yeah.
The things that could be measured.
I don't really know how you would measure it.
Yeah, I feel like it's more observing, like how much plasticine gets on the other pieces.
Are you using different colors?
Yeah.
You could maybe like measure if the or how much the colors blend or merge together. There's a fly in my room. I don't know if you guys can hear it, but it's very annoying.
Um,
I want to update Teams on my laptop, but don't want it to like, I don't know, log me out of this by any chance that could happen. So I'll just have to look at it on my phone.
yeah, it'll be a bit laggy, but oh well.
I'm just
You
waiting for this to.
do the edges. Sorry.
Oh, I'm just waiting for it to load. It will be there up on the screen in 2 seconds to be able to share it.
I guess you could not really measure, but see how the edges change from smooth to rough when you like slide it.
Yeah. I can't really think of anything else.
Yeah, neither. Okay. Guess the one thing we're changing. Oh. Okay. Sorry, it keeps putting me in full screen mode. I don't know why. Oh. Can any of you be not in full screen on Zoom and still type in Teams, or is it that doing it to you all?
Mine went into
No,
full screen, but I can get back out of it.
I cannot.
Oh, was that when I shared my screen?
Yeah, but normally I feel I can have it off to the side.
Hey Ash,
Yeah,
have
but
you got all of us visible on your screen?
Yeah.
Okay.
Cool.
Okay.
Oh, it's loaded now.
Then
Sort of
I'm not visible,
from
but she can. I'll just keep making
Are
sure.
you
that I'm
visible now?
all good. Alright, where were we up to?
The table of cows move softly. So changing one thing. I mean, I guess there's 2 experiments, but we could change. We're obviously changing the way we like the transformations. So like push, pull, and slide.
Yeah.
I don't know what to call that. But then we're also changing the plasticine and the egg. I guess that's a different experiment though.
I suppose
You
we
could say changing directions.
need, yeah, choose one of the things.
Or changing the force that's applied.
Yeah.
Is that what we're going to agree on? Oh, yeah.
If we're changing like push, pull, and slide, is that
Mm.
force, I guess?
Yeah.
Yeah.
And then the measure one thing can measure, I don't know, how the plasticine changes.
Yeah, like I guess
Yeah.
the appearance, like how it looks.
Yeah.
Could you measure it? Because if it flattens out, you'd be able to see that it, like, would you measure it, so to say?
I guess. I don't know if it'll flatten out because it's pretty hard, but I can measure it anyway.
I was just thinking, like,
And then the stuff kept the same. I'll keep the force. Oh,
The
Can you
amount.
So, because
is-
you just said we're changing the force.
I've put in there we're changing the type of force, but you can
Oh,
keep
okay.
the same
Did
the
you
amount
say-
of force.
Okay.
oh, did you disappear or was that only on my screen?
Who?
Renee.
oh,
No.
no, she's here.
Oh, okay. I don't know what's happening. Anyway. The type of plasticine, and the size, it's pretty much the same.
Yeah.
Yeah. Like how you're applying force, like how we're doing it, because we're using our hands, so keep that
Oh,
the
yeah.
same.
Yeah. Temperature as well.
Yeah.
Do we say like the whatever you're resting on the top?
Oh yeah.
What is it?
Yeah.
What is on it?
I'm just using a Jenga block.
A what? Sorry.
Jenga blocks.
Okay.
People use Monopoly houses, so I was like, yeah, I'll just.
Yeah.
I feel like that's enough.
Okay. The initial hypothesis, I kind of wrote in there like one for session 1 for the plasticine and then the egg. But if we want to do it another way, we can do it in the table and just make 3 for each.
Don't
I think
mind.
we just put it where yours is.
Yeah, we
Right.
can just do it there.
Okay. I feel like when we push it together, well, it's obviously going to move.
Yeah.
And not just bounce off each other. They're going to combine. So if
Yeah. We apply force and push the 2 pieces together, then they will
then they'll-
join.
Then
Yeah.
both pieces.
Like pull apart, won't it?
join together because the force is pushing the two pieces together, I think.
Sounds about right.
Hmm.
So,
I feel like when we pull it apart, there may be remains of the other color on there.
Yeah.
Because, I don't know, it's sticky.
I suppose you could just say because of the force applied though. But because it would have been pushed together, so when you pull it apart, you're breaking that bond or
Yeah. And when it's slid, friction, I don't know.
Well, they'll rub together and it'll kind of change the shape of them because the edges will like obviously change.
you'll
Yeah,
get
that's good.
we say then like the appearance will change as the edges have rubbed together. Is that what we said?
Yeah. It's kind of manipulating them and changing them.
I don't know if we should do this hypothesis now or after we do experiment 1.
We can just do it now if you want.
Okay, yeah, it might be easier instead of coming back up.
Yeah.
I feel like the eggshells could break if you push them together.
Yeah,
Yeah.
definitely. Because they're so fragile, they'll definitely break.
Hmm.
Whoa.
I don't know, pieces may fall. I don't really think much will happen pulling it apart because I don't think it'll stick in the first one.
Are we pulling them apart while they're like still on the egg?
Some groups I think did, but then in this like primary connections thing, it said pre-crack the shell of 1 hard-boiled egg. So I don't know if that meant on, but it said into 7 pieces, and so I just pulled off 7 pieces. I don't know. I think some groups did a bit of both, but I don't really
Yeah.
know how I was gonna crack, like push them together on the egg without breaking it.
Yeah, you just break the egg.
and so you
Yeah.
just break the
Yeah.
egg and like the shell would just shatter, so to say.
What do I say here? Sorry.
The shells, yeah, were cracked. I just feel like they'll crumble if we slide them. Or
Yeah, they will. They'll just kind of like just do what we pretty much just do what they did when they got pushed together, but less breakage.
yeah, maybe
won't be as-
smaller pieces.
Yeah.
And then it says to talk about how the research question, initial hypothesis, and CMS might change depending on if it was a higher or lower year. So I guess our hypothesis is pretty basic already. Like not,
It might just need more prompting to get to a hypothesis in the younger years, whereas in the older years, you might just, like, I don't know the structure, they'd be able to do it, come back, everyone have their opinion, and then everybody agree on one. That would be a difference.
Yeah.
yeah, more guidance, I guess, with the younger and less with the older.
Yeah. And just the terms you would use, I guess, with the older ones would be a lot more technical.
And then ask for definitions on those terms even. Don't just put something
Yeah.
on what it is.
I forgot about session 2s, but I don't know if we need, that's the one where I'm cutting the egg in half. So I don't know if we need an initial and final hypothesis, but I guess we could. I feel like we all know what the inside of an egg looks like.
Yeah. Yeah, I don't. Just leave that one, I reckon.
Okay. And then material and equipment, it said to ask you guys if we think this part's necessary, depending on the assignment. So I feel like it is.
Yeah.
I think so.
Okay. Done. I put the plasticine, the eggs, the block, the knife, and the desk in. But if you can think of anything else. Oh.
Yeah, there's not really much you need, hey.
Yeah. That's what I said. Yeah, I couldn't think of anything else. I guess a plate and a bowl to hold it, but
A Jenga block.
Yeah.
Oh, you put wooden blocks. Never mind.
right, Jenga.
Drink.
And then the health and safety. So what do we think some risks are?
Definitely kids eating it.
Yeah.
Yeah, the egg, because egg is such a common allergy.
Yeah.
Yeah.
I guess the sharp pieces of egg shell as well.
And the knife, if you have the knife in the classroom.
Yeah. And if they throw the plasticine at each other, that'll hurt.
Yeah.
Quite heavy.
Yeah.
Also being careful, because obviously we use the wooden Jenga block, like that's fine, but other groups may have used things like a glass cup or something like that. So just
Yeah. Or
being aware of what you used.
could be a choking hazard too.
Yeah.
I've spelled plasticine wrong every single time I've typed it.
Yeah, it doesn't seem like it has 2 eyes, but
No. Okay.
Oh, just quickly, guys. When you guys have recorded it, has it come up that you need to upgrade?
Yeah, and then it went away.
Oh, did it like do a countdown?
No.
Um,
Why is this? We
yeah, I
can
can
start
see
a new one.
Can you see that?
it got
oh,
when
I
it
can
got
see-
to like the 45 minutes or however long it was, it just said, "We've given you extended time."
I can see that it says like 9 minutes left.
Is that counting?
Yeah.
Yeah, mine
guess-
didn't do that.
Yeah, that's weird.
Yeah, this is. I just don't want to be cut off like mid sentence.
We can just re-record it like 9 minutes time. Hopefully it gives us a big warning.
Yeah, I'll keep an eye on that. Sorry, I just wanted
Yeah.
to. Yeah.
Oh no, that's okay.
We can do the don't eat it, don't the other stuff.
Yeah.
Yeah.
And then obviously the rules before the experiment. And then group roles, I guess, for the allergies, like people with allergies don't touch the eggs. Or if they smell it or inhale it, like breathe it in. Is that an allergy?
Any allergies?
Some kids do have allergies like that
Oh.
bad. Yeah.
If there was an allergy to an egg, you wouldn't even risk having it in the classroom.
Yeah.
It wouldn't be worth the risk. Of,
If we could find an alternative, or just use the plasticine, or I guess, I think we have to talk about this later anyway, but yeah, we could use something else instead of the egg for the second one.
I thought about like other foods, but then there's still that allergy risk. So
We'd
Yeah.
do different coloured Play-Doh, but then it'd have to be thin and like,
Oh my god, I hate typing on my phone.
it's actually going pretty, like it's not lagging that much.
Yeah.
it's like typing pretty fast from what I can see with yours tomorrow.
I just keep making spelling mistakes because it's not working.
We think that's all. Eating eggs.
For now, yeah.
Yeah, it's quite a few.
I think we've covered everything. except different. Oh no, well, no. Yeah, I think we've covered everything.
Okay. I'll try and take photos as we go as well. Just don't really forget because I probably will. But yeah, these are my plasticine pieces. I just have 3 of each colour and then I'll just do them in sets so we can see the transfer. Are we all ready to start or do you have any questions before?
I think we're all good.
Do you think that we should stop this recording just in case and start a new one?
Yeah, I'm thinking just because it says there's only 4 minutes, so if I stop it and I can just merge them anyway.
Yeah.
Right, so let me just go stop share. Right, I'll just stop it and then I'll send another link.
Okay, thanks.
Right, I will be.
I see Jade.
I can see everyone.
Everyone's back. I have everyone here.
That's weird. Oh well.
Can still only.
Oh, I just need to change the view options,
Yeah.
I think.
All right.
Okay.
Sorry about that, guys.
Okay. Well, I'll do it here. I might have to pick the pieces up. Because I don't think I can slide it on here. I think other groups used a piece of paper, like some of them, but it doesn't say that in here. And I feel like someone posted it saying like for extension work. So
Yeah.
do that. So the first one is push them together. And it says, ask the class to observe and describe changes at the edges of the plasticine pieces. So that's me gently. Oh, that's a bit of force. So yeah, it kind of went up.
Yep.
Okay.
Imagine doing it with a 20 centimeter sized one.
Yeah.
That's
That'd be
huge.
so good.
The picture they had was also this size, so I don't know. It says pull apart the second set of plasticine, but how do I pull it apart if it's already apart?
Yeah, if it didn't join. Yeah.
Like this one though.
Maybe using Play-Doh would be better because it would mold together.
I'll just do the same one. I'll just.
I'm gonna take a picture of it once it's pushed together as well.
Yes, thank you.
Did it say to use Play-Doh or plasticine?
Plasticine.
This thing.
Yeah, I nearly got Play-Doh.
Yeah.
Wish I did. Anyway, I'll pull apart the same piece, but oh, it kind of.
Oh yeah.
Yeah.
There's. I mean, no white really went on the pink, but. And then I'll do the next set just so the colours. Yeah, and slide them. I don't know. It kind of just tears it.
Yeah.
Just forms it. Are we meant to be writing this somewhere?
We're writing the procedure as we go, but Jenna, just take pictures of like everything as you're doing it, because I need to put them into the table.
Okay. That's the slide. Okay. And then I'll do it with the blocks now, and I guess the new piece as well. So, in the middle.
Should you take a before photo?
That I actually did. So, okay. So this is like the earth and this is the houses on it. So
Okay.
Oh, I was like, what are the okay? That makes sense.
Yeah.
I was like, what did I?
yeah, just
100%?
so you know why. Yeah, kind of just tips them.
Oh.
Then pulling it apart. Make it apart again. I don't know, just pulls the blocks apart too.
I suppose you could say like the structure of it was ruined.
Yeah, like if this, yeah, if it was an earthquake, this would probably actually break in half rather than
Yeah.
just go inside. And then sliding past. Yeah. I feel like Play-Doh might break easier. Maybe that's why they said plasticine, because it would just like mush.
I
Yeah.
think the plasticine represents the like how thick the plates actually are.
Yeah. Well, they said 1.5 centimeters. That's not 1.5.
Yeah.
Okay, I took all my photos. So if we want to do the table and the procedure for that one, and then I can start the egg one. I put a table in the results bit.
Yeah, that looks good.
Yeah, the other one didn't make sense to me, so I was like, oh. Okay. Okay, are we all ready for the egg one?
Yep.
Smells so bad. Okay, so yeah, I have, that's for the other thing. These are the pieces. Obviously not all the same because I don't know why we needed 7. Yeah. So pushing it. Kind of just broke where my fingers were. Like where the pressure's coming from my fingers. It's not really, it's mainly my fingers that just broke that. So I don't know. But I guess it still went up a bit. Yeah.
Yeah.
And
Let's take a picture of that.
thanks. Maybe I'll do the. Oh, I don't know. I don't know how I'm gonna pull it apart. Maybe I should do it on the egg. Hey.
I think you're meant to. It's harder, but I'm pretty sure that's what's meant to kind of happen.
Okay. Well, when I push, it breaks like that.
It breaks at the force. Yeah, the
So I guess we can just use. When I pull it away.
I think that kind of represents that you can see like what's underneath the plates when you pull it apart.
Yeah, and I think it's better than doing it in my hands because my fingers just snapped it before. I don't really know how to snap it past without open the egg, but oh, I guess it caused the earthquake, you know.
Yeah.
I'm so glad that was solid inside.
Yeah.
Oh. Egg shell. I guess we can finish writing the procedure after because they're pretty much the same anyway.
Yep.
Oh, and I was meant to ask if the procedure is necessary to write, which I think it is.
Yeah.
Would you do the egg one just as a demonstration, not necessarily as an experiment? Or as like a follow on? Like for students to do, like follow what the teacher was doing so then they could touch and see it? Like each perhaps individual student have an egg sort of thing?
Oh, true, yeah. Instead of them being in groups, they could each do their own force. Yeah.
Yeah.
Oh. Cutting the egg. I don't know if I meant to ask any questions, but this is meant to represent the earth, like the inner core, outer core, and all that mantle crust. And we've already kind of discussed it with the Play-Doh, but they just said to ask the kids what else you think you could use instead of an egg to represent this. So I guess we could use Play-Doh or, I don't know.
Another fruit.
Yeah, you could use like an avocado
Yeah.
or
That's a
I
good
don't
one
know.
because it has that seed in the middle of it.
Yeah.
Okay, I'm just gonna cut this.
Lucky it's not runny.
Yeah, I made sure before. So I guess the shell, and then there's only 3 sections to it though. Aren't there like at least 4 on the actual Earth? I don't know. We can learn about that later, but that's what that looks like.
That felt like a cooking demo.
Mm.
My hand smells so bad. Oh. And then I guess now the final hypothesis we can do. Should we do a final hypothesis for each, like push, pull, slide, or just one for all?
Oh, because they were all very similar.
Yeah. I reckon just one.
It was all
Yeah.
about force. So
When applying force to the plasticine, it moved.
Is this the part that goes like that we actually go into detail with like a couple of sentences?
I think so, yeah.
Yeah.
So we say like when it was pushed together, this happened, and then just write them all together like a big paragraphy thing.
Yeah.
Yeah.
We say like some color of one. Did it stick to the other one? A little.
Well, we didn't really. It did stick, but
Oh,
we
it
didn't
lifted.
it like
It like
yeah.
lifted up. Am I writing this right?
Yeah.
Yeah, you are.
Should we say how it changed the shape of it as well? I don't know if that's what you're going to say or not.
Yeah.
Yeah.
Oh, I mean, yeah, you wrote like it lifted upwards, but should we put like when it was pulled apart, the pieces remained lifted?
Oh yeah.
Because they sort of did, didn't they?
I
Yeah.
think I needed to use a new piece though.
Oh.
Yeah, I don't know.
You could say something still like just a general statement, like the way which the plasticine and the eggshell moved or collided or whatever affects affected the overall shape of like the edge or the crust of it.
Yeah.
You said crust?
Yeah, just say the affected the overall shape of the whatever we used. Yeah.
What happened when it was slid?
The shape moved, like,
Oh, it just kind of pushed it forwards, like
yeah. Of the force.
do you reckon that's okay?
Yeah.
Yeah.
Yeah, because it touches on all of them and then kind of gives an overall statement.
When the eggshell like was pushed together, it did crack, but it didn't like lift off the egg. It didn't like fall everywhere.
You'd think it'd kind of push up a bit.
Yeah. Let me look at the photo because
Do we say that it was cracked but not shattered? Or like cracked where the force was applied from?
yeah.
Yeah, along the like line of
Yeah, it did lift up a little. It just didn't detach from, which is good because that shows.
Do I say that it lifted off or did it not really?
It did a little. Yeah. I mean, could be because I peeled half the egg before, but when it was pulled apart, it came more detached from the egg.
yeah, you could start to see the white part of there, like the
Mm.
inner.
And then when it was slid, it actually cracked the egg white. And the yolk. Oh no, it didn't
Probably
crack the
cut it.
Did we see the yolk or when we did that?
Yeah, we saw a bit.
Oh yeah, okay.
But it didn't crack.
So it caused the inside of the egg to crack, but not the shell.
The shell cracked as well.
Or everything cracked.
Yeah.
Is that done, or is there? Do you want to add anything? Like a general sentence at the end, or
Overall, the force used changed the shape, changed the appearance of the egg. And then we would be done, but because it's the primary connections one, it said something about having, like, introducing the term tectonic plates, which we've been talking about anyway, and then
Yeah.
asking these 4 questions that I put in. So I guess that could be used like throughout the lesson. Well, actually, maybe not throughout the lesson, but this could be an introductory activity, and then the kids could discuss this and go away and research it to see if they were right. But obviously, we don't need to do that because we have the CDSU.
This could kind of lead into like your next lesson. So if you use this activity as your introduction, and then your next lesson could be like, okay, we did this. This is representative of tectonic plates, and then explain tectonic plates and stuff like that.
Yeah.
Yep.
yeah.
Yeah, so I don't know if we actually have to answer them, but
I feel like we just have to acknowledge them
Yeah.
and just have a general discussion. So
Yeah. Like those questions could form your next lesson, like Monet said.
Just gets them to kind of think and get them to make the connection between the two.
Yeah.
Yeah, so the edges, they changed shape or got other color on them. When one plate moved, the other did as well.
Yeah.
Because we applied force to both. How many different directions? I guess with those examples, they would say like all different directions. Like I know the CDSU, it's just, I think there's 3 or something, but I mean, they would say whatever because they don't really have stuff surrounding it. What happens to the gaps around, I don't know, it closes. Okay, if we want to do the CDSU now.
Yeah. Do you want to share it, Monet, or do you want me to share it?
I don't think I have it saved. I can if you, it's on your
That's
phone.
okay. I'll be able to share it, I think. Hang on, let me just see.
Are we still all good with the recording, Ash?
yeah, it hasn't. Oh, this meeting will end in 10 minutes.
Oh, it just came on.
Literally just popped up just as you said that.
Yeah.
Oh.
That's okay. We'll do the CDSU and then we'll see how we go for time. I'll go share screen. Oh,
Does it let you?
no, can you please let me?
How?
I don't know.
The 3 little dots.
Yeah. That should work now. Can you do it now?
Cool, thank you. Yep. Is that doing it?
Yeah.
Cool. Okay. Okay, so this is the CDSU which Monet and I did this week. This picture here just sort of shows where the plate boundaries are around the world, which we'll talk about. Yep. Oh, can you guys see the whole screen?
Yeah,
Is that better?
Yeah, it was fine. If you
it was fun.
Yeah,
Yeah.
that's one.
I don't know how this works.
Zoom back in.
yeah.
Okay.
Yes, pretty zoomed out.
That's good.
Monet, did you want to read this one? Since you
Yeah, I
read?
can do this one.
Yep. Thanks.
Okay. So starting off with, the Earth has so it has two different kind of layers essentially. Well, there's more, but there's two main ones. So you've got your compositional layers and your mechanical layers. So your compositional layers, they're determined by their components, so like their chemicals, and your mechanical layers are determined by their physical properties. So for your compositional layers, there's the crust, the mantle, and then the core, which is then broken down into your inner and your outer. So the crust makes up 1% of the Earth's mass, consisting of oceanic crust and continental crust. The mantle is hot and represents 68% of the Earth's mass, and the core is mostly iron, and it makes up 31% of the Earth. So for your mechanical layers, inside that you have the lithosphere, the asthenosphere, the mesosphere, and then your outer and your inner core. So the lithosphere, it's the outermost and most rigid mechanical layer of the Earth, and it includes the Earth's crust, tectonic plates, and the top of the mantle. So it's where the tectonic plates are situated. The asthenosphere is underneath the lithosphere, and it's around 100 kilometers thick, and it is a region of the mantle that flows relatively easily. It's where molten rock flows in a convection current, which Tamara will explain in a second. And the mesosphere is beneath the asthenosphere. It encompasses the lower mantle where material still flows, but at a much slower rate than the asthenosphere. And then our two cores, inner and outer. The outer is the only layer of the Earth that is truly liquid, and the core mantle boundary is the only boundary of the Earth's layer that is both mechanical and compositional. Flow of the liquid outer core is responsible for the Earth's magnetic field.
So on the next screen, I'm going to have to zoom out because otherwise I can't see the screen, but I'll zoom it back in after. So yeah, as Monet said, the tectonic plates lay within the lithosphere, which includes the crust and upper mantle of the Earth's outer shell. So this consists of the oceanic and continental sections, depending on if it's on land or below the sea. And these plates move around at different speeds and in different directions as they are each subjected to different movements and pressures. So there's 7 major plates, which are like highlighted in different colors on the picture. So there's the Pacific, North America, Eurasia, Africa, Indo-Australia, Antarctica, and South America plates. And then there's also some smaller ones which fit between them. So Monet, did you want me to read this? I don't mind.
Yeah, no, you can do that one.
Okay, cool. So as Monet said, also the convection current is what occurs, which creates the movement of the tectonic plates. So due to the heat produced from the magma, which is molten rock within the Earth's core, a convection current is created, which means the less dense hot magma moves upwards and the more dense cooler magma moves downwards towards the core. So it can occur very slowly or rapidly, just depending on the pressure from the magma that's underneath. Cool. And then there's just like a diagram there to show how it sort of moves around. So there's 3 different types of movements which we just sort of modeled. So it's the divergent, convergent, and the transform boundaries is what they refer to it as. So divergent is when the plates push away from each other, which you can see in the diagram there. Convergence where they push towards each other, and then transform is where the plates move along or slide next to each other. Monet, just let me know when you want to like read a slide.
That's right. You just do the ones you did, and I'll do
Okay.
the ones yeah.
Okay, cool. Yeah, so this is the divergent boundary. So when the plates move away from one another, magma rises up and fills the gap of where the plates once were. So if it occurs on land, a rift valley forms. So on the left, there's like a little diagram there of like the land, which is once joined, and then it moves away and like a valley forms, and then that can then fill with water and become like a river, or it might just like stay as dry land with no water. It just depends on the climate. And then when it's in the ocean, it's called seafloor spreading. So then that magma just creates new oceanic crust at the bottom of the ocean floor. Cool. So the next one is convergent. So when the plates move towards each other, the more dense oceanic plate goes beneath the continental plate. And if it's not like an oceanic and continental, whichever one's more dense goes beneath the other one. So if it was like oceanic and oceanic, whichever one was more dense would go under, if that makes sense. So where the plates meet is called the subduction zone. And then that's just the red spot that's on that diagram there. So due to this, due to the movement, the mountains can form if it's near the continental plate, which can also cause volcanoes to arise as well. So, yeah. So the next one is the transform boundary. So that's when the plates move against each other or in a sideways motion. So the pressure is released through the earthquakes, which can cause like tsunamis, flooding, or landslides. So that's sort of a diagram of how that would work. And then Monet has some more information on that.
It just says we have less than a minute.
Yeah, I just was going to say we might want to stop and read.
Yep.
Read that.
Yeah.
All right.
Okay, here we go.
Sorry.
Is it recording?
Yeah.
Okay, cool. Distance set on my screen. Is that the slide we were up to?
I think it was the one before. I'll just check.
That one?
Yeah, I think we did that one. Yeah.
Oh yeah, the last one was what was an earthquake.
Is that what's showing?
Yeah.
Okay, Monet, did you want to read that one? I think you wrote that one.
Okay. So it's important to note that tectonic plates move super slow. So over a year, they only move at around 3 to 5 centimeters. Some can move up to 10 centimeters, but it's super rare. Most of them stay in that 3 to 5 range. So essentially your tectonic plates are just massive irregularly shaped slabs of solid rock that are composed of your continental and oceanic lithosphere, like Tamara said before. So tectonic plates are constantly shifting as they drift around the mantle layer, and as a result, this constant movement causes stress on the Earth's crust. When this stress gets too large, it leads to cracks called faults. When tectonic plates move, it also causes movement at these faults. An earthquake is the sudden movement of an Earth's crust at a fault line. So if we look at that image there, you have obviously your fault line, and then there's an epicenter and a hypocenter. So the hypocenter is just the point within the earth where an earthquake rupture starts, and then the epicenter is the point directly above that at the surface of the earth, and it's also commonly known as the focus. So
Next slide.
Yes, please. So I mentioned faults before. So essentially what they are is they're just the crack in which you get between the two the plates, like the surface. So during an earthquake, the rock on one side of the fault suddenly slips with respect to the other. Faults are classified using the angle of the fault with respect to the surface and the direction of slip along the fault. So there are three types of faults. You've got your normal fault, which is a dip fault in which the block above the fault has moved downwards relative to the block below, which we can see in our little image. A reverse fault is pretty much just the opposite of that. So the upper block above the fault plane moves up above the lower block, and then your strike slip fault is what we kind of did in the activity as well, which is just where the two blocks are sliding past one another. The movement of these blocks along the fault is horizontal. Next slide, please. So on average around the world in 1 year, there are around 20,000 earthquakes that occur. However, not all of these are felt, as an earthquake needs to be above between 2.5 to 3 on the magnitude scale to be felt. In Australia, in 1 year, we experience around 100 earthquakes of a magnitude of 3 or higher. There's a lot more little ones that no one feels as well, so that's important to note. So over 90% of earthquakes, including almost all of the largest and most destructive earthquakes, occur either on or near the edge of tectonic plates, known as our plate boundaries. Majority of the tectonic plates movement is focused at these boundaries, which is why more powerful earthquakes are less common far from these boundaries. So our boundaries are obviously just the black lines, like Tamara said before. So if we look at Australia, where it's actually located in its tectonic plate, it's right in the middle. Our earthquakes are quite minor to those compared to countries which might be situated on the actual edge of the boundary. And some people, like kids, they might have the misconception that we don't get earthquakes here, which is false. Although we're situated in the center, we do feel earthquakes. This is because as tectonic plates move and tectonic plate boundaries have changed over millions of years, the weakened boundary regions become part of the interior of the tectonic plate, and these zones of weakness within the continents can cause earthquakes in response to the stresses at the edges of the tectonic plate or inside the Earth's crust. So it's essentially just saying that everywhere in the world gets earthquakes and does feel them at some point in time, no matter where the location is. And yeah, that's pretty much it.
I just wanted to add on to that. So you might not feel it like an earthquake, say in Australia, because if is it the hypocenter? Let me just check. Yeah, the hypocenter. If that is very far down towards like the lower part of the lithosphere, then we won't feel it as much. Whereas if it's closer towards like the crust of the earth where we are, then we'll feel it more. Cool. I think that was it. They are our references, which we didn't get time to correctly do. So we'll fix those up before we put them into the right-hand side document. But yeah, that's all. I'll stop sharing. Sorry?
You still want me to record just the discussion of the left-hand side, or should we stop recording so we could talk about that?
I think we still have to record it.
Both have to record.
Yeah.
Do we want to do an infographic for the left-hand side?
Yeah, I think we should do something creative or just a bit visual.
I think the infographic we did it looked really good last time, and And I've noticed when people like present, it's actually easy to follow. Like
Yeah.
like I don't know, the one last week it was just very like, oh, click here, wow, like I don't know, there's just more to look at.
Yeah, we can do that. I don't mind.
Find that on what was the website we used here? What's it called? Canva.
Well, yep.
Who wants to talk about what do we want to sort of assign when we present? Who like step through and then
I
we
think Mara and Monet do the CDSU
yeah.
because they did it. The scientific learning part.
But I mean, like, you know how everyone sort of like they sort of still walk through the activity in that, like all the other people that have presented, like somebody's explained the activity, then someone's gone through like work health and safety, and then the CDSU, and then like alternative conceptions and learning and that.
I don't think we should talk about that in our what we're
Yeah.
No, yeah.
activity or the health and safety, because she'll stop us because she's kind of asking us those questions afterwards.
Yeah.
So I think, yeah, if Tamara and I just do the scientific learning, and then if
Yeah.
we want to do pedagogical learning, and we won't mention anything like those 5 questions, and then if we make another
Yeah.
one, and we
Okay.
each just a question like assigned to us, because there's 5, so we each just have 1 question.
Yeah, I think it's sort of hard to talk about, like, to not talk about the questions because they're so broad and they cover pretty much everything. But I think like it's important that we try not to talk about them because that's what she asked us the questions for.
I noticed that last week. She said, "Oh, you've already answered the question," and it was like, "Oh, wait, they couldn't really."
Yeah.
But yeah, she'll still ask you to further elaborate, and if you've already said it, you kind of don't have anything else to say.
Yeah. I think we need to go through like those 5 questions now. I think we're supposed to keep it on the recording.
That's right. I can get it back up.
Copy and paste the health and safety.
Yeah, the curriculum's already in there as well.
Kind of discussed, not really, but how we would make our way from the initial lesson to the assessment.
We sort of discussed too catering for diverse learners at the beginning when we said about just like providing more scaffolding to the younger years and more independence in the older years. I suppose that could just go across the board for diverse learners as well, scaffolding, prompting, giving templates that students can go off and follow through just to still be involved in the activity as well.
And like changes with the egg for people with allergies as well.
So could we just...
I'll just put in like how it relates to numeracy as well, and literacy with the I forget what it's called, but with the words that are like, sorry. You just cut out. I missed what you said.
How me? What I said?
Yeah.
Oh, I wasn't going to say anything. I didn't say anything.
Oh, okay.
Do you mean we're in the catering for diverse learners?
Oh no, sorry, I meant in the curriculum part. I just didn't. I just didn't say that.
No, that's all good. I was like, oh, hang on, what? Sorry. Does that read okay, everybody?
Mm-hmm.
What I've written hasn't updated on your teams.
On my teams, on here.
Where did you write?
I put in under the cross curriculum part, I've got numeracy and then literacy.
Oh. Should I read it?
So I've put numeracy, so measuring scale and estimation. So like if students need to measure like the length for the plasticine, and then also sort of understanding the scale. So when they look at the egg, how that relates to the earth and like the scale of it. So the yolk and then the egg white and stuff and the shell for the crust.
I would have put it in there, but I don't want to like.
Oh, that's okay. It'll probably come in a minute.
But the Indigenous perspectives as well. It says about researching their cultural stories that provide evidence of geological events.
What did you say? Sorry. I was trying to fix this.
Indigenous perspectives.
Yeah. That's weird that it's not coming up.
Yeah, I just sort of was. General capabilities. Did you put something in there or just the other?
No, I haven't.
No.
I haven't yet.
I always forget the general capabilities. I always have to look them up.
There are
Oh, there it is. Oh.
Literacy, critical and creative thinking. Something else that I can't click on. Numeracy.
Hang on, let me see if this will fix it.
It just came up. Numeracy, literacy.
Oh.
It's there.
I just changed it.
Oh.
Oh well. All I wrote was, for the general capabilities, numeracy, measuring, scale, and estimation.
That's still up there for me.
That's in cross-curricular.
Oh, yep. Okay. Yep. It's really slow. Oh well, I did move it to go under general capabilities.
Oh, yeah. All good. As long as we know what we're talking about when we get asked that question.
Yeah.
We can answer it confidently.
And then also estimation, because they'll be estimating what will happen in the hypothesis. And then, yeah.
Is that all we need to sort of cover though, for general capabilities and cross curricular?
I think so. I'll have a look at the curriculum, and if there's anything else I find, I can add it.
Great. Do we need to talk about any like examples with diverse learners? Like, I know now one-on-one teacher assistants. Like, do we need to elaborate more on that? Like, if that's a question that she asks us.
Yeah, probably.
I do the
Put that in there.
PowerPoint, I'll add more like
Yeah.
Okay.
Well, you could get students who, like, if they have a special interest in tectonic plates or in earthquakes or volcanoes, they might, like, the teacher might want to ask them if they can explain, and then have them share their ideas. And then obviously correct any alternative conceptions if there are any.
Our health and safety is pretty standard. Our assessment opportunities.
get them to do a group presentation for the summative of like what they found.
Discoveries, like each group's discovery. They'd all have to come up with like a way to present what they discovered. That'd be fun.
They'll probably all have different results as well because they're all obviously going to do it differently.
And they could even go off like what was I going to say, like try and bust a myth sort of thing with it, because there's so many misconceptions about, I feel, this topic. They could at like the start of the unit come up with, you know, all these myths around it, and then every group pick a myth and they bust the myth. That could be a fun like lead in summative assessment to it. Yeah, that looks good. And then that's just our CDSU. Is there anything that we need to cover that we haven't?
I feel like if we remember anything, we can just add it before Thursday.
Yeah.
Okay, yeah. Cool. Awesome. Are we happy to stop recording?
Yeah.
Yeah.